Units of measure. Units of measure are so incredibly important, yet they are often overlooked. You're doing a long, complex equation in physics, and you come out with an answer of 5, and you leave it like that. Well, what can you do with that? What importance is what? Who cares 5 what? I know what I'm talking about. Well, a lot of this deals with communicating with others. This is all about trying to make it as simple as possible for other people to understand. So, if units don't matter, then the answer to everything is 1. Because you can always find a unit, even if it's made up. How tall am I? Well, I'm 1. 1 what? Well, 1 George Fox. So, it's as simple as that. However, it doesn't communicate anything because no one else knows what a George Fox is. So there have to be some standards that we're working with here. So, units of measure. With my very sophisticated slide here, and the multilingual nature of physics and life in general, muy importante, très important, and sehr wichtig. I hope these are correct translations. It came off the internet, so it must be true. Now, when dealing with units of measure, there are lots of different systems. So, for example, if you're talking about, well, no, that's a different one. 3 basic systems. The 3 basic ones are metric, and that breaks down into MKS or CGS systems, and US customary. And US customary, sometimes I'll call British units or English units. Actually, US customary is based off the English or British units. Now, MKS and CGS are both metric, and there's easy conversions back and forth. M stands for meters, and it stands for centimeters. That K stands for kilograms and grams, and then S stands for seconds in both of them. Actually, all 3 of those systems, they have seconds. Why? What difference does it make? Well, the difference is the derived units. If I'm trying to find the mass of something, I can find it in kilograms, I can find it in grams. It's no problem. I can convert back and forth by either multiplying or dividing by 1,000, depending upon which way I'm going. But if I'm trying to find out force, well, I'm trying to compare, I have a 2-gram mass and I have a mass that weighs 5 newtons. Well, which one's more? Well, there's an easy way of figuring out one from the other, assuming you identify a location, because it's not a conversion. Force and mass, and weight is a force. Force and mass are not converted, but there's an easy factor depending upon if you know where you are. If you don't know where you are, if you don't know this thing called acceleration due to gravity, if you don't know your location and that value, there's some approximations you can use, and we'll get into that. So the difference is that in the derived units, that if I'm dealing with the MKS system, then my force should be in newtons. If all my lengths are meters, all my masses are kilograms, and all my times are seconds, then my force is in newtons, my energy is in joules, and so on. It goes straight down the line. And so that way I don't have to track units while I'm doing my math. All I have to do is just pop in units at the end. If I'm starting out with these basics, and I'm going to show you a couple others, if you start out with the basics, then my speed will always be meters per second. My velocity will be meters per second and some direction, indicated some other way, and so on. Now, there are 7 basic units from which all other units are derived. Length is the quantity. In an SI system, it is meters, little m for meters. Mass, units, kilograms. Time, seconds. This is the MKS system, also known as the International Standard, otherwise known as the SI, which stands for Standard International. And for those who speak French fluently, I apologize for my pronunciation. All right, so I've got, try to get my hand out of the way. So, electric current, temperature, amount of substance, and luminous intensity are the other 4. Those are the 7 basic quantities, and those units are the basis for all others. Now, so electric current in the SI system, or MKS system, is amperes. Temperature is Kelvin. That is not degrees Kelvin, it is just Kelvin. Amount of substance is moles. Don't worry, we're not going to go do moles too much. And the last one is luminous intensity, and those units are candelas. not used as much as the others. Moles I only use in chemistry, but you could potentially go to the grocery store and ask for, I'd like 1 10 to the 23rd moles of eggs. And you're roughly asking for 6 and a little bit. It's an awkward unit, and so that's why it's not often used. In terms of that, if I'm talking about if I have a collection of people in the room, I'm not going to do it in terms of moles, I can do it in terms of people. So there are conveniences for communication. However, when it comes time to doing scientific papers, sticking with one system generally works. Thank you very much.